feel free to introduce yourself and we can start. All right. So we have Alvin, and Alvin is lead systems analyst for Visa Inc., Foster City. We have Malready, who has 6 years of experience, 6+ years of experience. Great to have you in the class, Malready, Alvin, Sunny, and Narendra, and Roni. Great to have you all in the session. Okay. And we have Rajsekhar, Rahul, Masood. Great. Wonderful. Wonderful to have all of you in the session. I can see your profile. Most of you are having a great experience, and Rahul has an experience in Scala as well. That's nice. And okay. All right. Welcome Sahida, welcome Abhishek, welcome Rahela. Feel free to introduce yourself so that we get to know each other in the session. Wonderful, wonderful. I'm very amazed at the profiles of the people who are joining. And great. Good. So first of all, welcome to the session one of Hadoop and Spark course from No Big Data. All right. And this session is going to be up to 11 p.m. IST or 1:30 a.m. ET. I think it's correct. And this is 3 hours duration. And first half, we are going to discuss the basics of big data. Then we'll take 10 minutes break at 1:30 hours, 1 hour 30 minutes. And then in the second half, we are going to discuss Hadoop and Spark architecture. The session is being recorded, and the recording will be shared with you after the session, as well as presentation will be shared. Who are already the students? These sessions and the recordings will be available. These sessions and the recordings will be available in the LMS. Okay. So except for me, everyone is muted. So please ask your questions by typing them in the chat window. I'll try to read out the question before answering, but the question is generally visible to all. So try to address the question to everyone. Okay. And also keep your message short and avoid chat language. All right. Good. So welcome to No Big Data. All right. These are the few important parts to know about No Big Data. We have expert instructors or mentors, and we have lab. We provide lifetime access to LMS, which contains all the slides, recordings, assignments, quizzes, and project works. And we have something called assessments. All right. I hope people are able to hear me. Is anybody able to hear me? Yes. Okay, so even one person is able to hear, that means I'm doing good. Okay. So if audio is not working, please check your machine settings, and everyone is muted. except for instructor. Okay. All right. So if you have performed great in our classes, we generally connect you in our real life project, and we provide you a course completion certificate once you have submitted the project and you have finished the assignments. And although we do have sometime course attendance certificate if you really need it, if you just want attendance certificate, that we can provide you. We provide you 24/7 support via email, and we have the groups and the communities to so that you can stay connected with others and jobs and stay updated with the new technologies. All right. So out of around 14 sessions, although here we have listed only 12 sessions, this generally goes up to 14 sessions. And in the last session, it went more because there were few questions which people wanted the answers. So we extended the course to around 15 sessions in the last one. Okay, since we keep on updating and making the course better and better, so they expect that the course might go a little longer than what we have promised you. All right. About myself, I did my graduation in 2002 from IIT Roorkee. I did my BTech from there, and then joined a company called DE Shaw. It was a very interesting company. So where we built big data systems before the term was even coined. What I mean is we had 10,000 nodes cluster in 2002, and our data used to come via flight because we could not download it every week. It was so huge and the network was slow. All right. So a question from Sudhakar, do we cover MapR in the course? Yes, we do. All right. Any questions? Just give me a minute because somebody is calling me. All right. So I worked at DShaw for 3-4 years, and then I started a company called T-Bits Global, which was into document management systems. And then in 2012, I joined InMobi, where we churned around 200 terabyte of data to build the recommendations. Okay, 200 terabyte data was really huge, and it was very important. Let me see if I can mute everybody. I'm actually getting distracted because the new journeys All right. Thank you, Pradeep, and thank you in the send to let me know. Actually, I had finished my call. It's just that I forgot to unmute. Okay, so I'll repeat what I was saying. So in 2002, I did my graduation from IT Roorkee. Afterwards, I worked with DE Shaw, where that was my first interaction of humongous data. And the one thing I came to know that time is it's important to have a grid computing. We used to call it grid computing. We had 10,000 nodes cluster where we had to distribute the work and get it done via traditional means. We bundled our own script and we used to call it framework for big data. And that time Hadoop wasn't there. And after DE Shaw and DE Shaw, I realized one more thing, that the dynamics of computing changes entirely when big data comes into play. For example, traditionally we are used to transfer the data over the wire. But when the data became humongous and every week we need to process it, we had to transport the data physically, as in our data used to come via ship or aeroplane. That was faster than the electrons in the wire. Can you believe this? This is where the data, this is where the data plays a significant role in the computing. Okay, are you able to hear me now? Because some people are complaining that they are not able to hear. All right, great. And then I founded a company called Tbits Global, which is into document management system. And then I worked with Amazon and in Mobi in churning humongous data. This was my third experience within Mobi and fourth experience with Amazon to deal with humongous data. Even in my own startup, we had worked with we had worked with humongous humongous data, not that huge to be called as big data, but it was complex in the structure. Then we started no big data because we realized that in industry, most of the people who are training are traditional trainers. They don't have experience in 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 building the products or working with humongous data. That was the sole reason why we started no big data. And we have been able to achieve that excellence at no big data, that we have our students have performed really well in the industry. Also, to give our students a great experience of learning, we try to achieve what is there in Amazon or in at any professional environment, the lab, where people can do hands-on and do as if they are in the production environment. That's where we built CloudX Lab. And CloudX Lab became quite popular. Now, we are very happy to be the pioneers of CloudX Lab. And as of today, a few other institutes have also started providing the lab. And okay, so this lab has become quite useful and has become a separate entity in itself. All right. Okay, in today's class, we are going to discuss basics of big data. Why are we discussing it now? And then, all right, and then we are going to go through the entire ecosystem of big data that will help you. All right, so a quick question to all of you is, what do you understand by big data? Yes? So what do you understand by big data? Nice. Good answer. Keep going. Keep going. All right. All right. Um, is it better now? Any better now? Okay. All right. In case this again happened, please let me know. I'm yet to figure out what exactly happened. I just unplugged my headphone and put it back again. All right. This has happened for the first time. All right. Let's get back to the big data part. Let's get back to the big data part. So we were discussing what is big data. All of you had answered the question very nicely. And I would like to reiterate or summarize whatever you have said. Big data is simply data of very big size that you cannot process with usual tools. And when I say usual tools, what does it mean? The tools such as a usual database, a tool such as a file system, that's the usual tool. So when you cannot use these usual tools, the traditional tools, to handle the data, then we generally call it big data. But The definition does not end here because there is always um, confusion about what is usual and unusual tool and how big is the data. So we'll try to make it more concrete. Okay, the usual tools are those which are not distributed architecture based, and these tools that are required to handle big data are generally distributed in nature. We'll talk about distributed in a minute, and the data can be of any type, whether structured, unstructured, or semi-structured. We'll talk about these definitions in a minute. All right. So what do we mean by structured data? Structured data is the data which has the data in which we know exactly how many fields are there and what are their data types, so that we can simply write query on that data. That's structured data. The data in databases is a great example of structured data. We know exactly concretely the number of columns, the type of columns, and the name of columns. So such kind of data is called structured data. And then comes semi-structured data, the data in which we know how many columns are there, we know how many fields are there, and what are their names, but we do not know what are their data types. For example, data in comma separated values, CSV file. We know that the data is comma separated, and we know that these many columns are there, and first line is the header, but we do not know what are the data types of each column. That's called semi-structured data. The third one is where we neither know how are the columns separated or how are the columns represented. Neither we know how many columns are there, nor we know their data types. Such kind of data is called unstructured data. Such kind of data is called unstructured data. All right, I hope everybody is with me on these definitions. The example of unstructured data is the logs, the error logs. Error logs is what? When you run a server or you run a program, the program keeps writing to a file, whatever is happening within that program. That's called log. So this log is an example of unstructured data because there is no clear demarcation of the fields. It's not in the form of tabular. It's not in tabular format, or we don't know the fields. This is unstructured data. So to convert unstructured data into structured, the process of translating unstructured into structured is called ETL, extract, transform, and load. We will learn ETL processes on big data using Hadoop as well as Spark during the course. All right, the other buzzword we used was distributed computing. What does it mean by distributed computing? When groups of networked computers interact with each other to achieve a common goal, that is called distributed computing. All right. So distributed computing is, or distributed system is a system in which there are many network devices. They have been connected over a network and they are interacting with each other to achieve a singular common goal. Okay, this is called distributed computing. Okay, so the difference between distributed and parallel computing is distributed and parallel computing is, in parallel computing, you have many CPUs and a single RAM or memory, and we want to divide our work on many CPUs or many processors, and the memory remains same. While in case of distributed computing, the devices are connected in the network. So there in the parallel computing, the RAM is the way over which the various processors are talking to each other. While in distributed computing, the computers are talking to each other over network. All right. Although, very important thing to understand, the fundamentals of dividing the work into more than one processor, those same algorithms with which you divide the work into multiple processors, the same fundamentals apply in distributed computing as well. Okay, therefore, most of the algorithms that have been designed for parallel computing, the same apply in distributed computing. All right, a question from Subham is, isn't every server running on DOS? So most of these servers actually run, as of today, they run on Unix. Okay, most of these servers run on Unix, although Windows is coming up with newer machines, newer OS, and that time maybe the systems would run on DOS. So a question from Subham is, DOS, when he said DOS, he meant distributed OS. I'm sorry. So distributed OS, so this is generally, what we are going to understand is, we are not going to use a singular distributed OS. Instead, we are going to use something called YARN, which behaves like a distributed OS. So no, there is no distributed OS as such as of today. All right. We are just going to use a higher level software component on top of existing OS. All right, now let's talk about 3 characteristics of big data. Also, this is a traditional definition. I'm going to stick to my definition here. This definition, I'm going to stick with this. This definition is what makes me, this is the definition which will guide us during the course. All the components, around 18 components that we are going to discuss in this course, all of them are distributed in nature. And we will try to solve problems using distributed computing. We'll try to convert our problems into distributed. All right, we will learn that part as part of this course. All right, so these are basic traditional 3 characteristics of big data. And this is something very salesy, or you can say very, how should I say? This is very marketing-ish definition. All right, but it's important to discuss it, because if somebody asks you about 3 V's and you can't answer it, they will think that you have not studied big data. All right, so there are 3 characteristics of data: volume, velocity, and variety. Volume is how much data do you want to store, the static data. Velocity is how much data, how many queries you want to handle, or how much data you want to transfer per second. And variety is what kind of problems are you trying to solve? Variety and complexity, we're going to put it in the same bucket. What kind of data transformation you're going to do, or what kind of problem are we trying to solve? Okay, there could be many different kind of problems, and those problems would be either data structure or algorithm related. Okay, all those problems we bucket them into variety. All right, so when we say that we are Facebook and we're going to store hundreds of terabytes of data per day, where will we keep this? How would we solve the problem like storing hundreds of terabytes of data per day and then being able to retrieve it when needed? So this is volume related problem with the data. Second one is velocity. Velocity is being, let's say, we are Facebook and we want to handle thousands of requests per second or hundreds of thousands of requests per second. Everybody's mobile is all the time refreshing and connecting to Facebook to get the updates. Similarly, everybody's phone is connected to Gmail to get the latest email. How would we handle so many requests per second? That's velocity. And as I'm talking right now, this data, let's say by the end of this session, we must have transferred around how many? 54 candidates. So 54 into 1 GB minimum, we would have transferred by the end of these 3 hours. So 54 GB data we would have transferred by the end of this session. That's velocity. And third one is variety. The problems involving complex data structures, such as maps, social graphs, and recommendations. Maps, social graphs, and recommendations. All right, let's talk about variety in a little bit more detail. All right, Sunny, I'll come back to this question. So we are talking about the 3 characteristics of data. And so let's talk about finding directions, or finding a way, finding a path from my place till, let's say, somewhere in the US, right? And you're given the entire map. Now, even though the map could be hardly, say, 20 gigabytes of data, it's not a problem of volume. It's not a problem of velocity because the data is not moving so fast. But since there are so many paths from every point to every other, and we have to enumerate over so many paths, therefore, problem of finding a path from one point to another is a complex problem. And this complexity, we say it in the variety. So our data, our problem, either by virtue of its volume, velocity, or variety, could become so complex that we cannot handle it using traditional tools. And we need a system which is a distributed system to find a way to solve our problem, whether related to the volume, velocity, or variety. So we need a distributed system which can solve our problem in a reasonable amount of time. All right, coming back to your questions. Sunny's question is, isn't veracity a form of big data? So I'll tell you a very important point. These are the 3 basic characteristics of data. Okay, if given a chance, I will rename variety to complexity. volume, velocity, and complexity. Volume is handled by databases or file systems, while velocity is handled by the systems like NoSQL, in which the data needs to be modified, and variety is handled by these new machine learning tools such as ML, and GraphX that we'll study in this course. And therefore, these are the three basic characteristics. Now, what has happened is everybody has been adding more and more V's every year into this definition. And at the end of all of this, we might have V for vendetta added by me into the definition. All right. So there has been value, visibility, veracity, and I don't know what else is there as part of this definition. So I would like to keep our focus very sharp on the problems that we are trying to solve, and keep the marketing separate from engineering. Okay, so we are going to focus a lot on engineering, solving the problem related to volume, velocity, and variety. And of course, all of this is to give the value to the customer and the visibility to the customer. And all of this, when faced by engineers, is called veracity. I have removed actually the veracity from the definition. Okay. I hope I have been able to answer your questions, Sunny and Murthy. All right. Okay. So we're going to keep our focus on this. All right, Murthy, are you around? Ian Murthy. All right. Was I able to answer your question, Murthy? Yes. All of you, I mean, most of you would be going ahead with the rest of the course as well. Okay, so also there is no obligation to all of you to join in the main course. All right, actually the truth is that the class is full, so we don't have spot in the main class. All right, so there's no obligation at all. And second, to all of you is, please keep your questions coming. The only way to learn anything by questioning what I am teaching and by questioning what you are hearing. Okay, so that's the only way to learn. And for some reason, we have been tuned to not question, because somewhere questioning has been uh, regarded as what do you say, a bad thing. Okay, by all kinds of social structures. But I request all of you again to keep your question flowing. By asking a question, you will be clearing your doubt. Uh, second, if you don't clear your doubt, rest of the session will kind of black out for you. Third, same question might be there in somebody else's mind, and they might not be asking you, asking the question. So you might be doing a favor by asking question. All right. So keep the question coming. You might be doing somebody a favor, as well as you will be clearing your doubt, and do not lose the sight of the entire course. All right. Do not worry that the course will get delayed. Don't worry that part, because that's my responsibility. I'll take care of the course. All right. If needed, I can extend the course by a couple of classes, because I'm in no hurry in order to rush. Okay. There's no worry to not ask question. A question from Pius is, can Hadoop is a replacement of NoSQL databases? Not really. Okay, Hadoop does provide a database component called HBase, but there are many people who run Cassandra or other systems on top of Hadoop. Okay, so Hadoop can coexist with your systems. All right. So if you don't have a NoSQL database already, you may want to give a try to HBase. The problem with HBase is it doesn't have sophisticated querying engine. Okay, it has the HBase is good in the sense that it can handle petabytes of data easily, but it doesn't have a great sophisticated query language like Cassandra. But you can have Hadoop and Cassandra together in the network. Subham's question is, can't big data be divided considering individual or more of these characteristics? So I would say this way, you can classify your problems based on these three characteristics we talked about. Okay, you definitely can classify. Okay, and that's how you generally work out. There is something called lambda architecture, in which what you do is your data is coming at a very fast pace from the user. On one end, you keep on pushing it to Hadoop static data store. On the other hand, you keep on processing it. And that's how we simplify our big data architectures. All right, so you are quite right there. All right, did I make sense to you, Subham? Um, uh, Zabulo, I did not get your point. Please send us an email of times the class starts. So the time that class has started today, it is the same time that we are going to start, which is 8 p.m. IST, 47 minutes before this instant. All right. So that's how it is going to be. And there are going to be around 14 such classes Saturday and Sunday. Coming back to Rajsekhar's question, petabytes of data is stored in one computer or distributed across computers? Very good question. And yes, very quick answer is it is stored in a distributed fashion on many computers. And that distribution could be by the use of Hadoop distributed file system and some more. Okay, good question. And moving ahead, Sydney's question is, could you mention some of the tasks, things that cannot be achieved by big data or limitations of big data? All right. So limitations of big data or the problem that cannot be solved by distributed computing. Okay, big data is a data which is big, right? So big data is not a tool, not a solution, not an architecture. Okay, let me be very clear in the terminology. In the marketing, these blogs and the whole marketing machinery of IBM and all these organizations, they have confused that big data with the tools and solutions, okay, or the architectures. But we cannot afford to do that. So big data means big data, simple. Second question is, what kind of tool, what kind of problems cannot be solved by distributed architectures, right? Few of the problems that cannot be solved are related to training the certain neural networks. Similarly, few of the problems are, let's say, where you need all the uh, data to be at the single place on a single machine. Those kind of problems cannot be solved with distributed computing. Okay, so training is one such example, training of neural net data or neural net or some other. while there are other kind of tasks which can be, there are other kind of machine learning that could be done on distributed computing. Okay, Rahul's question is, velocity means requests coming per second or data generated per second. Okay, so velocity means both. Okay, the request coming per second may or may not generate data, right? If you're not storing anything, you may not be storing the data that is coming from the request. Let's say there's a website counter which is just updating a number every time a request comes in. So you are not really generating so much data. Therefore, velocity may or may not generate huge data. All right, very good question, Rahul. All right, so yes, very good point, Siva Basappa. Possibly one of the limitations is the ability to have transaction. Very good point. Thank you. Yes. So the one thing that I did not include in my answer was when you have to deal with transactions. So transactions are a difficult thing to handle by a distributed system, because if we try to make things transactional, we will have to deal with only one machine. And therefore, the whole purpose of distributed computing gets defeated. Therefore, most of the systems cannot handle, most of the big data systems or distributed systems cannot provide great transactions. Okay, we will understand by the way of CAP theorem, and we will try to understand why such kind of great transactions are not supported by most of the NoSQLs and most of the distributed computing environments. All right. Now, how many petabytes, how many bytes are there in a petabyte data? Anyone? Okay. One more question I would love to answer before that. Krishna's question is, does it support update data? Yes, it does support update data. So most of the systems, we will understand it by the way of CAP theorem, that why it makes sense not to provide very strong consistency on your data, meaning providing the transactions and other kind of consistency. It doesn't make much sense on humongous data, but there is a newer term called eventual consistency, meaning right now there is no consistency, but in few seconds there will be consistency. We will go into more details about the discussion. All right, Krishna. All right, so how many bytes are there in a petabyte data? Rahul says 1 million gigabyte. Okay, all right, good. So you are right. Yes, so this is how we kind of represent it. All right, so 1 byte means 8 bits or 2 nibbles. There is something called nibble, which means 4-bit equals a nibble. Okay, and each byte can store 8 bit of data. You can imagine 8 switches up and down, and the total each switch can provide you 2 states, on or off. Using these states, you can generate many states, and that's what we call it data. Okay, and the way to memorize it is kilo means 1024 bytes, and so is mega is 1024 times kilo, and so on. Kilo, mega, giga, tera, peta, exa, zeta, iota. This is how you can remember the number of bytes. Now that we know what does it mean by 1 petabyte data, as well as what does it we as well as we know what does it mean by big data. So my question is 1 petabyte data big data? Is 1 petabyte data big data? You might ask that what are the problems that we are trying to solve in order to give the answer, because as I said, big data is just data, and when we say something is big data or not, we are concerned about handling that data, processing that data. So question is, what is it that we are trying to process? If somebody asks you this question, your first question would be that what is it that we are trying to do, and what kind of data is this? What is there inside the data, and what is it that you're trying to achieve? Then I can tell you whether it's big data or not, or whether distributed computing is required or not required. All right? So now, question back to you is, if you have to count just vowels in 1 petabyte data every day, your task is to count vowels in 1 petabyte data every day. Do you need distributed computing system? Do you need a distributed system? Yes or no? You just have to count vowels, and counting vowels is not a big deal. You just have to keep 5 numbers in the memory, read data from left to right, keep on increasing the counter, or you just have to keep one vowel, one long number. And as you go through the data, you just keep on increasing this number as you encounter a character which is vowel. It's pretty simple. The logic is probably 2 lines logic, right? And right here we are saying that, can we solve this problem every day? So first question you're going to ask is there, have you already built this storage, or you want me to build? I'll ask you that, can you build such a storage? Then you'll say, okay, I'm going to create so many systems, connect it to the network, and put some data on this, put some data on that, and then I'm going to read this data and count the vowels. Now, again, can you do that every day? Can you finish counting vowels in 24 hours? Yes? Using your classic system? That's correct. Siri's answer is no. You cannot finish in 24 hours using any traditional system. And the reason is, all right. So let me go ahead. Yes. Yes. So the traditional systems cannot handle a petabyte data so easily. All right. So most of the systems cannot handle this kind of storage. We will understand why as we go forward and we discuss Hadoop distributed file system. Why was it built? Then you will get the answer. Yes. Thank you, Rahila. All right. So it's going to be impossible, almost impossible, to get 1 petabyte data stored and then processed by any traditional tool. All right, a quick question to all of you. How much time does it take to read 1 terabyte data from hard disk drive? Okay, let's say you have a new hard disk and your friend has got a 1 terabyte hard disk full of movies and you want to just copy it. How much time do you think it'll take to read? Just read, I'm not saying write. Okay, let's say you just want to go through all the movies, you want to read it once and say, just do nothing. So a question from Subham is, depends on processor and hard disk speed. Why does it depend on processor? Because reading the data is not a function of a processor. The bigger bottleneck is the hard disk. Your second answer is right. Okay, depends on the memory. Why should it depend on the memory? We are not reading into memory. I did not say we're going to read it into memory. We're just saying we are reading it. Maybe we are not doing anything about it. Maybe we are just counting vowels or counting a particular byte in the 1 terabyte data. It's the I/O operation, as Siri says, that takes maximum time. Yes, Sunny, you are right. The disk head has to seek and the position itself for over and over again for the blocks. Yes, and that's the reason why it would take fair amount of time. All right, coming back to it, it would take around 6 hours. Okay, this is a very important number to understand. Just reading data from one disk to another would take around 6 hours. All right. So the faster the hard disk platters spin, the faster the data can be read. Thank you again, Rahila. Yes, so the important part to understand, and as we do the processing, as we learn to solve the problems, and as we learn to classify and figure out that, and as we go ahead, we will learn how would we do the back of envelope calculation on figuring out whether this should be done on many computers, so this should be done on a single computer. We will learn this as we go ahead. All right. So as per the hardware specifications, it takes around 6 hours to read this 1 terabyte data. Just read, not write. Write will be around 5 times slower, which means it's going to take 30 hours to write, copy data from one hard disk to another. All right, now question to all of you is, why is big data important now? As you can see in this graph, in 2002, the data explosion, digital data, not analog. Analog means in the books, in the paper, in the print format, that's analog data. Digital data is something in the digital format, in something that can be quickly converted into electrons. That is digital data. And this digital storage has been expanding, exploding since 2002. And 2002 was marked as the beginning of the digital age, meaning the year of my graduation is that. Now, why is it important now? Why is it important now? I'll say two things. Hardware and communication. On one hand, the hardware became cheaper, faster, and smaller. If you have a friend who is into hardware design, ask them about what has been their KPI, key performance indicator. They will tell you that our organization's objective is to build cheaper, faster, and smaller chips. So every hardware manufacturer has been working really hard to make hardware cheaper, faster, and smaller. Because of which because of which we have this wonderful device called mobile phone as of today. We have this wonderful device called mobile phone today. And this mobile phone that we use it for playing Angry Birds or playing Pokemon Go, this wonderful device is actually more powerful than the supercomputers of 2002. All right. So the supercomputer that was like the talk of the world at a point of time was slower than your mobile device in the hand. All right. On the other hand, the communication, the connectivity has improved a lot. We have Wi-Fi, wonderful speed, and we have optical fiber network, and and then 4G, 3G, and LTE. So there are lots of communication and connectivity as of today. Because of connectivity, these classes what I'm having now, these classes have been made possible because of connectivity. And in this class, we have participants from across the globe. So on one hand, the hardware became powerful and became popular. On the other hand, the connectivity became omnipresent, and the ability to transfer the data became faster and better. So these two things together made it possible for new generation of softwares. And the social networks is an outcome of this hardware and the connectivity. Because of this, we have software, and hence there's more and more data. Data is being generated by devices, whether it's your phone or whether it's the sensors, IoT sensors that are generating data. And this data, when it gets transmitted to many people, that gets multiplied further, and therefore the data becomes bigger and bigger. As I tell you that because of connectivity, I'm able to transfer my audio right now and video right now. While because of the hardware, I'm able to speak, and it is basically able to transfer. And therefore due to the software, so all of these three things combined are generating big data. All right. Now, a quick question to all of you. Which of these components impact the speed of computing? CPU, memory size, memory read speed, disk speed, disk size, network speed, all of the above. CPU, memory size, memory read speed, disk speed, disk size, network speed, and all of the above. Correct. All of these components impact the speed of computing. While we all have been sold that it is the Pentium P4 that is the most important. But as we will discover going ahead, CPU is not that important to make your computer faster. Okay, probably it'll be the RAM or maybe disk speed. If you replace your hard disk with an SSD from your laptop and you increase the memory of your computer, the chances are your computer will become around 10 times faster. Okay, so it's all of the above. Now let me go into more details. So on a very grand scale, we break down the computer into 4 components. Of course, there are motherboard, there are connectivity, there's this sensor, that sensor, and there are all kinds of other peripherals attached to the computer. But when we say pure computing, we generally talk about 4 components. Network is something which we have included now. And we'll understand why network is important. All right. The first component or the first pillars of computing is CPU. Number of instructions that it can handle per second is the characteristic of CPU. And the more number of instructions it can handle per second is called is better, and it is called its frequency and measured in gigahertz or megahertz. Generally, most of the computers are above 1 gigahertz as of today, and we have multiple CPUs, multiple CPUs in a machine. Second is RAM. RAM is the memory from which CPU keeps reading back and forth and stores the data. RAM or memory is the same thing. There are two characteristics of the RAM, which is how big is the RAM and how fast is the RAM. Okay, most of the RAMs have similar speed. So speed is generally we are not looking for in the RAM much, though it does matter a lot. And size is something more important in the RAM. Third is disk size. Disk is something where we store the data. Even if we reboot the machine, the data will be there. And disk or hard disk or drive, they are the same thing. Okay, HDD, disk or hard drive is the same thing. Size and the speed both matter a lot. Okay, so if you buy, instead of hard disk drive, if you buy solid state drive, it will be faster, but it provides a smaller size. Okay, the fourth one is network. So while hard disk helps us to store data permanently, the bigger the data, the better the data. But since hard disk is also slower and is also insufficient, we would like to store some of the data in the network. And that's where the network becomes important. And in today's time, our problem generally involves downloading data from somewhere or uploading data somewhere, reading data from a network, and so on. So all of these, most of our work gets impacted because of network. Slower the network, and slower will be our data reading speed from a network, and therefore we'll not be able to finish our work faster. So these four pillars of computing are important. And as an engineer, we will keep on juggling between these four components. For example, if disk read is taking too much time, we will push data to the RAM. If RAM is full, we'll push data back to the disk. If disk is getting full, we will put data into the neighborhood in the network, and so on. So we'll keep on juggling all of this um, all the time. Sometimes we want to build an algorithm so that we don't have to read too much data, or we have to read less times and from the RAM, and so on. So and that's the computing, that's the algorithms, that's the data structure. And we try to do that all the time. We try to juggle between these four components all the time as part of computing. And at least one of these components becomes the bottleneck when it comes to big data. At least one component will become such a bottleneck that you cannot solve it using one computer. Either CPU becomes a bottleneck, or RAM, or disk, or network, and such that it becomes impossible to solve the problem in a reasonable time. And that's when we call it big data problem. All right? I hope everybody is with me. Great, great. Okay, so keep asking questions, because that is the only way to learn, and that's the only way I may know that I'm able to convey something. Okay. So coming back to the practicality, the real world, there are many big data customers. The web and e-commerce. All right, let me answer Subham's question. Would not it be more suitable to call it that of a big data system than generalizing it to for normal system as well? This is whatever I'm discussing. It is actually true for the normal computing as well. Okay. So whatever I've discussed in the previous session, I hope this is what you meant. So this is basically true for handling humongous data. All right. So this is true in the case of normal systems, that we have these four components that we keep on trading between as an engineer or as a developer, as an architect. We keep on trading between these four components. And when it becomes impossible to clear the bottleneck caused by any of these four components, we call it generally and we call it that we may be able to solve it using big data environment. But it's not necessary that all kinds of bottlenecks be solved with big data systems. Okay, some of these bottlenecks could be solved with big data systems. All right, did I make sense, Subham? Great. All right, so keep the questions coming. And I totally love the questions. And why my sessions are popular, why people like to attend my sessions, is because to get their questions answered. Otherwise, all of this gyan, all of this knowledge is spread over the internet. So I would suggest that keep the questions coming. If you have slightest dark spot in the mind, that this is something I'm afraid of, this is something I don't know about, feel free to ask. All right. So that's the most important part about my sessions. Okay. All right. And this would be my maybe 30th class or maybe more. And the reason I've been able to give the sessions for so long period is because of answering so many people's question, because that's kind of make me feel good accomplishment. All right, so coming back to the big data customers is the web and e-commerce. The first one which could convert data into money was these e-commerce companies such as Amazon. For example, most of their sales happen because of the recommendation engine, the recommendations that they have built. Because of that, a lot of their sales happen, okay, either by showing those recommendations on the email or on the web. They have proved that they're able to bring in a lot of customers from recommendations. If they just keep on blasting people with an email of products, people will mark them spam. Nobody will like to see it. But if they send great list of products that might be useful to you, and you realize that wow, this is very similar to what I was looking for, then you would not mark their emails as spam. Okay? So I'll try to explain recommendation before going further. A recommendation system is something which gives you the suggestions on various things based on various form of data. If it doesn't have data, they would like to show things like people who bought this also bought this. Or when they don't have any data, then it generally shows that people generally wear this with these. Or recommendation could be more involving, that people like you with your kind of history liked these kind of movies. Okay, So the such kind of recommendations can be handled easily using Mahat or using MLlib. We're going to use MLlib in this session, which is Spark's machine learning library. And we're going to use it to demonstrate a couple of examples, such as movie ratings. And we're going to build your personalized recommendation engine, meaning in our last class, what we did was we are given a list of movies. I gave you the history of around 1 million users, that these people like this movie this much, and and then you have to mark your own movie preferences, and then it will generate movies for you. Okay, so that's what we did recently in the last class. We'll do it in the same thing in this class as well. That way you will feel great about doing the problem. Movie recommendation for yourself. Okay, so th this is called recommendation. All right, this is called recommendation engine. So recommendation engine work great if they have huge data. If they have less data, they don't work well. Why so? Let's try to understand what does a recommendation engine do. It basically tries to figure out which users are similar to each other and then tries to cross-sell each other. Let's say me and Chaitanya like the Matrix movie. I'll take an example again. Let's say me and Chaitanya like the similar set of movies. For example, in this example, what we have shown on the screen, Kumar and Giri are similar to each other because they at least like one movie out of total 3 movies. And therefore, it is okay to cross recommend things. So similar, first it tries to figure out similar users and then gives a recommendation of one user to another. All right. So this is how most of the recommendation engines work. All right. There are slight deviations as well. Okay, that might go beyond the scope of the session. All right. Second is the search quality. What does it mean by search quality? Okay. So search quality, there are many more dimensions when it comes to search. All right. As of today, if you are searching something on Google, you get the results. And when you click on a result, you go on to that page. If you stay for a little longer on that page and you don't come back for very quickly, Google will realize that you really like what you found on that page and will increase the ranking of that page. So that's the first indication. Second is the quality of content on every page. Along with that, how many people are referring back to a page from the internet. So improving search quality is a very tough job and it requires humongous data. Now, your question would be that I'm not going to build a Google-like search engine. I'm only trying to build a small search engine for my organization where we have around, say, 1,000 users and we have few gigabytes data. Then do I need to bother about big data because I have just a small data and small number of users? The answer is yes. I mean, I have built a small search engine for my document management system. And that time we realized that we needed lot of data. For example, when users are searching for blue dart, it could be blue space dart, or it could be BLUDART. There could be many other variations. So these variations could be easily tamed if we from a humongous corpus of data, if we are able to figure out that this particular phrase is written in so many ways by the users. Okay, so even if you are building a search engine or for a small data, still you might have to churn big data to understand, to give great experience and to give great quality of the search. Did I make sense to you? Yes. All right. Great. Third is sentiment analysis. It's a very important question, that what does it mean by sentiment analysis? Sentiment analysis means figuring out what people are talking about you or your brand, whether how many of the people are talking positive and how many of the people are talking negative. And that's where the problem starts. Okay, there are many ways to figure out this. One dimension of sentiment analysis is the data sources. What are the data sources are you going to use? Whether Twitter or whether Facebook or whether some other. Second dimension of complexity of sentiment analysis is what algorithm? How are we going to find whether a particular message is against you or for you? Meaning, is it positive or negative sentence? All right. And if you accumulate it, the result would be the sentiment analysis. All right. So this kind of sentiment analysis is complex because it sometimes it involves understanding the language. Similarly, it also involves handling fast coming data. Therefore, a sentiment analysis is a big data problem. So we will do the sentiment analysis as part of our course, and we will use natural language processing on the cluster, on the distributed environment for computing the sentiment from Twitter in a real-time way. Okay, in a real-time way. But since we don't have the paid subscription is really costly of Twitter, we'll try to use their free subscription. That should be good for our analysis. But if you want to go for really, I mean, the real sentiment analysis from Twitter, then also the approach will remain the same. The hardware might change. Okay, so same program could run on handling millions of tweets per second. Okay, we'll show you that our approach can handle around 3 lakh messages per second. That's a very good number. 3 lakh messages per second. Okay, that's velocity as well as the complexity as well as the volume. Okay, so fourth is A/B testing. What does it mean by A/B testing? But before that, there's a very interesting question from Hung Lee. Would sentiment analysis be based on the culture? It can be, and I would love to, mentor you if you would like to build such a thing. Okay, so as of now, we use the English language, ability of English language to parse the data. Basically, we use the libraries which parse the English language and try to understand English language. And we would love to see that. Okay. Fourth is A/B testing. What is A/B testing? What is A/B testing? A/B testing, meaning this term comes from medical background. And this term comes from medical background. And in the medical terms, a medication is given to the patient, some of the patients, and the other patients are not given the medication. Other patients are given just the pacifier, a false medication, just the water drops. So half of the patients are given the medication and half of them are not. And then we observe that medication had any impact on the patient or not. We observe the performance of both the sets. Okay, sometimes we call it control and treatment. Okay, control is the set where no medicine was given. Treatment is the set to which the set of the patients to which the medicine was given, and we compare the results. Sometimes both control and treatment set, or A or B sets, is generally not equal. Okay, generally not equal, as in control is 90% and treatment is 10%, and so on. So yes, yeah, placebo is a better word. And I'm not sure if A/B means alpha beta. Okay, so this term comes from medical background, but it's very much relevant to the computer engineering. At Amazon, we use A/B testing all the time. Let us say somebody comes up with an idea that, okay, we will implement blue button, blue buy now button. Okay, and somebody said, no, we will use orange. Somebody said red. Okay, instead of arguing about the color preferences or cultural preferences, the way we operated at Amazon is, let's implement all three. And we will show these buttons to a small set of users and observe how is the performance. Are more sales happening from red, orange, or blue? And based on that data of running it for a couple of days, we take a call whether it's time for moving to orange, yellow, and orange, blue, or red. And that's how most of the people today, most of these engineering companies, such as Facebook or Google search, they improve their results. Okay, this is the right way of figuring out what is right. Okay, for example, the orange button is generally the is has won against all other buttons. So the button, that's where we also relied on the data that Amazon has gathered. The buy now button should be of this color, no questions, because they have already done the fairly good amount of testing. Similarly, for example, after testing my interface for quite some time at Amazon, we realized that my mobile app version of the detail page at Amazon, it is working well. So it has been put into production slowly for more number of users. Okay. All right. Now, telecom companies. Okay. Let's continue from telecom companies after the break. So we'll take a break for 10 minutes and we'll be back by 10:45 p.m. IST. All right. So I'm back. Should we start now? All right. George, are you able to hear me now? Great. Wonderful. So let's start with where we left. Actually, one step back. So we talked about A/B testing. So this is an example of A/B testing. Say, for example, 50% of visitors are seeing variation A, and 50% of the visitors are seeing variation B. So out of red and green, which one do you think is better in this? Yes, that's right. So out of the testing, the result is that the variation A is better than variation B. Great. All right. Second thing we discussed about is sentiment analysis. Okay. Basically, plotting the positive and negative sentiments against a timeline is sentiment analysis. Now, this data, it involves two parts. One, gathering the data. Second, converting the data into sentiment. All right. And both the processes are complex as well as velocity intensive or data intensive. Okay. So the other big data customers other than the e-commerce company is government. Government uses big data tools because government also has a lot of data. They use that data for fraud detection, say for example, anti-money laundering and cybersecurity welfare and for justice. Then in the telecom world, we have we use big data to do the customer churn prevention. What is customer churn prevention? It is to figure out or to prevent users leaving, customers leaving a company. And how do they do it? So some of the telecoms, what they do is they try to understand the behavior before the customer left. Okay, what were the calls, how many times the calls were made to the customer support, and what was the geography, what were the coordinates, and what were the signal strength, and for how long the customer stayed connected, and so on. And these all data points help them figure out what went wrong and what went right. Next is network performance optimization. So network performance optimization is a very crucial part of the telecom. So I'll give you a very good example. So a few months ago, one of the customers came to us. They wanted their big data problem to be solved. They wanted their big data problem to be solved, and the problem at the surface looked like very small. The problem was they have equipments in each tower, and these equipments configuration is kept in XML, and this XML keep on getting modified by the operators from time to time, and they wanted to figure out a correlation in this. Now, in telecom, Now, in telecom, every data is huge. Okay, even these configuration files were huge. So figuring out, I hope the voice is okay now because I've put the headphone in the neck instead of on the head. I put it around the neck. So network, when it comes to telecom, every data is humongous. Okay, so even task like figuring out configuration file is actually humongous. Okay, the next is the calling data records analysis. As I said earlier, everything in telecom has humongous data, and therefore even churning the data calling the rate is impossible without big data systems. Then trying to predict the network failure or trying to predict a hardware failure is again a very crucial part, and that involves both volume as well as complexity, because everything at telecom or government level, it's actually huge data, and trying to do the prediction is tough on humongous data. Same is the case with healthcare and life sciences. They basically, all such organizations have already started using data. All right. So for healthcare and life sciences, they use big data for managing health information, for managing the information exchange, for doing the gene sequencing. The problem is really humongous, and therefore big data systems could solve such problems. Similarly, for healthcare improvement and drug safety, big data tools are used. All right. So yes, big data tools can be used in banks and is being used in banks. Except for the transactional data or transactional information, everywhere else, big data systems have started taking place in banks. All right, good question, Zabulu. And all right, I'm not sure how to pronounce your name, so I'm trying my best. And all right. Okay, all right. So Rahila's point is, of course, for database storage and account details, etc. Correct, correct. All right, so let's talk about the possible big data solutions that people use today. One of the combination is Hadoop and Spark combination. Hadoop and Spark combination in the sense that we install Hadoop and then run the computation on Spark. This is a very powerful combo. It's a powerful combination in which you get best of both worlds. It's both are open source and you don't have to transfer data outside. Second is Cassandra and MongoDB individually. Problem with Cassandra or MongoDB is it just provides you a way to data store or query. It does not provide you great computation engine. You might again have to fall back to say Spark for processing data. All right. The fourth one is Google Compute Engine or Azure or Amazon. So all these three options, if you try to use there, your organization, your company may not like it because you're trying to transfer the data from the walls of your organization to a third party place. Okay. Also, transferring data from one place to another continuously is going to be time consuming. Okay. So these are 4 different stacks. All right. So Prasun's question is, HDFS is used to store data. Why do we need MongoDB or Cassandra in a Hadoop ecosystem? You don't. You generally use HBase or MongoDB or HBase instead of MongoDB or Cassandra. Okay. Also, if your question further is, when we have HDFS, why we need HBase, we will talk about it in a minute. Okay. Subham's question is CouchDB for static data. No, actually CouchDB and MongoDB are very similar in nature, and both provides a good way of updating. Just that they only provide storage and querying, not complex algorithms. Okay. So Tegun, I will come to that answer in a minute. That's a very important question, and I would love to give it its own time. All right. So these are the general approaches where we try to build our solution. Either we install Hadoop Spark or maybe Cassandra or MongoDB, or we go for third-party solutions such as Google Compute Engine, AWS, or Azure from Microsoft. So all the last 3 ones, Azure, AWS, and Google Compute Engine, all 3 are basically where you put data outside your organization. Sure, I will go into each tool and applicability. All right. So let's start with our understanding of Hadoop. Okay, so there are a few good questions. Let me try to answer these questions. Sunny's question is, given a data set, how can we regard it as big data? Do we need to do a quick V-factor test? So I would say the question that I asked you, is a petabyte data big data or not? That's the quick back of the envelope calculation you have to do. All right. You generally try to see that which one is becoming the bottleneck. All right. So once you try to answer that, you will get to know whether it can be solved with distributed computing or not. All right. And as we go forward, while we try to solve multiple problems, we will get these answers. Okay. Piyush's question is about the 4th point in the previous slide. Okay. Is it about processing code on data? So Google Compute Engine basically processes data, right? So both you have to put there. So code will be running on data, and therefore mostly you process data at GCE or Azure or AWS by uploading data there. Okay. Okay. Did I make sense to you, Piyush? So GCE also provides you storage, and yeah, GCE also provides you storage. You generally upload data there They also provide you algorithms, and you can put your code there and process your data. So they provide both volume as well as the way to handle many requests per second. All right, good. A question from Nitesh. If I have to use big data for a real-time system, which tool should be used? So somewhere you're going to use, so it'll depend on what do you mean by a real-time system. Okay. One, you could use Storm generally for real-time system handling of requests, or you could use Spark streaming for handling data in real time. Okay. All right. So in the meantime, if you get some time, I've written a blog post here. Okay. I'll give you, yeah, this is the blog post we have published on CloudX Lab. CloudX Lab and No Big Data, both websites are same as in it's from us only. Okay. And all right. So you can take a look at how we build our real-time analytics solution. That should help you in answering your question, Nitish. Okay, a question from Subham, big data in IoT. Okay, so yes, in IoT, what you have is IoT is Internet of Things, where all the things are trying to get connected and generating data. If you have thousands of sensors installed at various places, and all of these sensors are generating data continuously, then what happens is you would need a database which can handle so many requests per second. Similarly, you will need a system which can store so much of big data in humongous size. Okay, so you will need a big data solution in IoT as well, provided you have enough data points coming in. If your sensors are being stored at a very small level, let's say 10, 15, or 5, those kind of data can be handled by normal systems. Okay, a question from Zabulo. So using big data is cheaper than using data warehouse storage tools like Teradata? Generally, yes. Also, Teradata is not sufficient at many points. Okay, when your data grows into hundreds of terabytes or petabytes, generally the non-big data systems, non-distributed systems do not help you much. Question from Rakesh. So we don't provide Hadoop admin training as of now. All right. Question from Subham. What tools should be good for that? What tools should be good for that? Let me see. So generally, the data stores, NoSQL data stores, such as HBase, which comes with Hadoop, Cassandra, or MongoDB, are sufficient for IoT. All right. A question from Krishna, is Teradata not a distributed database? I'm not sure. Honestly, I'm not sure because the people who talk to me are coming from Teradata database background. They generally are trying to migrate to Hadoop because of humongous data. Okay, I'll have to maybe go back and study with the Teradata architecture. All right. A question from Pradeep. What is Storm and is it similar to Spark? Storm is specifically designed for handling real-time data, handling velocity. But Spark streaming is Spark provides a library called streaming, which is very similar, which is also used for handling humongous data per second. And that's why we said either use Spark streaming or Storm. Okay, we'll compare the two. Okay, and most of the work that Storm does can be very well done with Spark streaming. But sometimes when you want latency less than 1 second, then it is better to go with the Storm than Spark streaming. A question from Subhan. Is there no false alternative to Hadoop plus Spark? There are alternative, okay? There are alternative, and we will talk about those alternative while we talk about Spark. And as of today, Spark is probably the best computational engine. And the file system, with respect to file system and other NoSQL, Hadoop and HBase are doing pretty good. All right. There are open source alternative. As I've told, MongoDB and Cassandra both are open source. All right, let's move ahead. Should we? Great. All right, keep the questions coming. I'm really liking your questions. Okay. And I'm sure with your questions, others are also getting benefited. And I do not want to take questions at the end of session because by that time you must have already blacked out. Okay. A question from Krishna: is MongoDB and Cassandra need to be mounted on Hadoop file system only? No, not really. MongoDB actually works well with the normal file system. It doesn't work well with HDFS. Similarly, in the case of Cassandra, they don't use Hadoop file system. That's right, Pradeep. We use Cassandra, MongoDB, HDFS, HBase to store data, while Spark or MapReduce for processing data. And should we need to learn Cassandra and MongoDB? Not much, not really. Okay, not really. Spark provides you a way to represent data in the form of database table, whether the data is from Cassandra or MongoDB or from HBase, from HDFS, and then it lets you query that data, okay, using either R kind of syntax or SQL kind of syntax or using programmatically. So that's Spark in very simple words. Okay, so Spark lets you represent remote data as a table, and then you can process that data using SQL query, R kind of query, or run complex algorithms such as graph algorithms or machine learning algorithms on top of data, or you can process using your custom code. Okay, that's Spark. So Piyush's question is, knowledge of Java help in understanding Hadoop and Spark? Not really. It doesn't matter. As long as you know any programming language, you should be able to get on with these things. Okay? Why I say any programming language? Because to really appreciate Spark or Hadoop, you need to be able to execute SQL, or you need to be able to execute your own code. A question from Piyush: Google file system was concept only or practical implementation? Google file system was a paper published by Google. They used the same implementation internally, but they did not make that paper public. Sorry, they did not make the implementation public. They only made the paper public. Okay, so no software was made public, but the paper. Okay, and Hadoop was an HDFS was an implementation of Google file system. A question from Manu: Hive and MongoDB is similar? No. Hive is mostly for churning data, although it has started to provide a way to modify data, but that is still in a very nascent stages. Hive is mostly for querying data, while MongoDB provides storing, updating, deleting, and so on. All right. And MongoDB runs independently, while Hive runs on top of MapReduce, which is a part of Hadoop. Krishna's question is MongoDB alternative to Hadoop? Not really. It just provides a small part of what Hadoop provides. Pradeep says, got it. We can use Spark for querying and processing. What is HBase? We'll talk about HBase in a minute. Okay. A question from Srini: why was Spark introduced? Was Hadoop not enough to implement the solution using MapReduce? So Srini, quick answer is Hadoop MapReduce was wonderful, but Spark is better than Hadoop MapReduce. Okay, Spark is better than MapReduce because it's faster and it is easier to program too. MapReduce was a little restrictive. Okay, we will understand that and you will appreciate it when we use it. MongoDB is similar to Cassandra, yes. Okay, Manu's question is, so when we use Hive and when we use MongoDB, when we want to process relatively static data, as in you want to process kind of read only, then you generally use Hive. But when you want to give velocity, a lot of requests are coming in, you want to update that, in those cases, you want to use MongoDB. Okay. Wonderful, wonderful. A question from Masood. Can Power BI tool of Microsoft can be considered big data tool? I'm not sure because Power BI does not seem to run on many nodes. Okay, so I wouldn't call it big data tool because my strict definition is distributed computing. But as a general term, the way this term is being used today, probably every system is a big data system. Okay. I have around 1 million Word and Excel documents to be processed. Do I need to store these data in Cassandra, MongoDB, or HBase before processing? I would say that you store these kind of documents into HDFS. That will make more generalized storage. Okay. A question from Piyush. MapReduce is part of Hadoop. Yes. MapReduce as a framework is part of Hadoop, although MapReduce as a programming language construct is part of Python, Perl, and even Scala. Most of the languages, today's languages, provide MapReduce as construct, just like for while loop, they have MapReduce as part of constructs. Although MapReduce is a framework which is part of Hadoop. A question from Sahida: is big data a concept or a technology? Big data is a marketing tool that represents humongous data. Okay, so we will keep big data to be very clear. Big data is humongous data. Okay, when we say can big data be used here or there, we would generally say can a big data solution required here? Okay. Pius's question is, and Spark is alternative to MapReduce. That's correct. A question from Karmugilan. A question from Karmugilan. Okay, I'll call you Kar. That's better. Yes. So a use case, do you want to know a use case where both NoSQL database as well as Hadoop is required? All right. So I'll give you a good example. A classic case is, let's say you are crawling a lot of data from the web and you are also trying to put their sentiment at a central place. Even the example like this, real-time analytics, a lot of data is coming in continuously and you are analyzing the data and you're storing data in the form of files as well as in the NoSQL. You're updating the statistics. In all these such cases, you will require both a NoSQL as well as say HDFS and MapReduce. Okay, Hadoop is a bigger term. All right. Okay, so I hope that answers your question. So there are quite a few use cases where you will need both. Or I would say this, that Hadoop has a NoSQL database. So sometimes you may not require any external NoSQL. A question from Ravi, do all these big data related tools have several APIs to interact with each other? If all of these tools use different file systems to store data. So yes, they provide a way to interact with them via API and REST interface. All right. Some of them don't, and they become kind of restrictive. All right. We will talk about these in details as we go forward. In case of Hadoop ecosystem, almost everybody uses Hadoop file system. A question from Vikas. In terms of data variety, do we need to analyze which tool will be more efficient? Okay, I mean Hive, MongoDB, etc. I would say when data variety comes into play, you think about data complexity and think about the tool which provides best libraries in machine learning and best libraries for ETL. Okay, that is the more important question to answer. And in case of data variety, as of today, Spark seems to be the best solution because it provides great ETL and great libraries to do the machine learning on various kinds of tools, various kinds of data. A question from Manu, will Kafka be covered? Okay, this question earlier also somebody has asked. In this session, towards the end, we will discuss Kafka to understand how do we do the real-time data processing, which is coming from Kafka. So we'll do the basic one, just the basic interaction with Kafka, how to create a topic, how to push data into Kafka, how to read data from Kafka, and how to read data from Kafka using Spark. This we will cover, and we will also cover a hands-on example on Kafka and Spark integration. Okay, a question from Mohsin. Spark is to process data and MongoDB to store data, then where does Hadoop fit in this infra? So we will discuss this in a minute, Mohsin, and you will get your answer. All right. Okay, a question from Pius. My use case is processing 5 lakh of records using ETL. Currently, I'm using Cassandra only and Java code to process. Can we use Hadoop in this case? Will it introduce any performance issue? Okay, you can use Spark in this case because Spark makes sure that it runs near to Cassandra, the code, and it will improve the performance actually. Okay, how much of percentage Hadoop, Spark versus MapReduce, MapR is being used in industry? Okay, are there specific use cases? So I don't have exact number, okay, on all these three. So I will not, I would not like to misguide you here. All right. But my gut feel right now is that most of the people who were using MapReduce have moved on to Spark. And therefore, there are, I mean, we'll discuss it as we go forward. All right. Okay. A question from, all right. As a design decision, we use Hadoop stack or traditional databases, assuming semi-structured data. So most of the big data tools are not for great design or bad design. Why these tools are used is when you realize that your existing systems, your existing architectures cannot handle that kind of load. Okay, then you generally go for these tools. Okay, when you go for Hadoop stack or Spark stack or MongoDB or Cassandra based on what is it that you are trying to achieve. All right. So I think, all right. So Rajsekhar and Subham, okay. Let me go over the stacks, okay. That would answer your questions. Most of your questions would be answered as we go through complete ecosystem. Okay, your questions are actually around the ecosystem, and by now I should have covered that part, so your questions would have answered by now. All right, so be with me. In case your questions don't get answered, please ask it again. All right, it'll be difficult for me to go back and try to judge it. Okay. All right, so let me talk about the two ecosystems, and then you will have a better clarity. All right, so in very simple words, Hadoop was created by Doug Cutting and Mike Cafarella. It was based on 3 papers: Google File System, Google MapReduce, and Google Bigtable. Google File System became Hadoop Distributed File System. Google MapReduce, the paper, was converted into Hadoop MapReduce, and Google Bigtable was implemented as HBase. They were trying to build a search engine, their own personal search engine, and they named Hadoop after the toy elephant. So it's open source, Apache open source. Why? Some people ask me why Hadoop is so powerful while not others. Because its licensing is the most liberal licensing. You can use Hadoop in your commercial application without worrying about paying somebody. Okay, it has Apache license. Next, it is powerful, popular, and well supported. It's a framework to handle big data, and the way and Hadoop has become an umbrella term. Hadoop has become an umbrella term. It's an umbrella under which there are many projects. All the components that come under that umbrella are reliable, scalable, and for distributed computing. Reliable, scalable, and for distributed computing. What does it mean? Reliable as in, if one of the machines go down in the network, these tools work. If today you have 5 machines, tomorrow you have 20 machines, still.
First repetition.
Sorry, please mute yourself. Hello? Third is for distributed computing, meaning being able to distribute the work in order to accomplish something. Okay? Most of the tools in Hadoop ecosystem were written in Java. Right? This diagram is something let's talk about. The most important part of this ecosystem is Hadoop distributed file system. Also, before Hadoop distributed file system, there is something called Zookeeper. Zookeeper is like a centralized registry, and that provides a very powerful way of coordination between big data systems. We will talk about big data. We will talk about Zookeeper in this course as a first component. Okay? Then we have Hadoop distributed file system, the most important component and the first component of Hadoop. This is where you store data in the files and folders. So a Hadoop distributed file system is a place where you put data in the form of files and folders. Now this file system has got some special capabilities. It runs on thousands of machines. It can run on thousands of machines. It can run on 3 or 4 machines as well. Okay, so by accumulating all the hard disks of those thousands of machines, it is able to provide you hundreds of petabytes of storage or thousands of petabytes of storage or more. Okay, that is the power of Hadoop distributed file system. All right, so this is the file storage where all the machines keep data in this. And Hadoop distributed file system is nothing but it distributes your data on many computers. It cuts files into pieces and distributes it. We'll go into the architectural detail in the second session. The second most important component of Hadoop ecosystem is Yarn, yet another resource negotiator. Yarn is kind of a distributed operating system. We ask Yarn, can you execute this particular program on 20 computers near to this particular data? And Yarn will do that for you. It keeps track of which machines are busy, which are free, which one have low resources, and so on. And accordingly, it executes the program that user gives it. Okay, the end user doesn't use Yarn directly. Instead, they use MapReduce or Spark. Those are called workloads. Okay, Yarn is a very generic operating system like framework which keeps track of which computers are free, which ones are busy, which ones are near to the data, which ones are away from data, and so on. And when somebody asks Yarn to execute something, it executes on many machines based on the user's requirement. Yes, all of these are softwares. Okay, all of these are software, and most importantly, some of these are like services. They run at a particular port listening to your queries. HDFS is a service, Yarn is a service, and HBase is a service. Okay, and Hive provides you also a service. Yet another resource negotiator. So Krishna's question is, does Yarn track the CPU availability or only storage? It basically tracks CPU availability, not the storage. It only tracks which file is closer to which machine. Okay, because as I said, HDFS stores data in a distributed fashion, and therefore, all right, next component is HBase. When you want to store data in the form of tables, not in the form of files and folders, then you use NoSQL database such as HBase. So HBase provides you this humongous table kind of structure, which has millions of columns and billions of rows. Columns and rows can be inserted at any point, and you can keep on adding value in every dimension possible. That's HBase. Okay, HBase saves data into the HDFS. Just like MySQL stores files into your local file system, or Microsoft SQL keeps the data files somewhere in the file system. Similarly, HBase stores data in the local file, in the HDFS. All right? HBase is NoSQL database. All right. Krishna's question is, why do we need HBase when we have distributed file system to store data? Is that your question, Krishna?
Yes.
All right. Okay, can you keep your user muted? Because I'm not keeping the headphone on my head. Instead, I'm keeping it on my shoulder. All right. So the reason is, it's a very good question. Why do we need HBase when we have the HDFS to store data? In HDFS, we store data in the files and folders, right? And other thing is, when you are storing things in the files and folders and you have to modify a particular line, you have to rewrite the entire file, which is wrong, right? Because if you are continuously modifying a file, modifying the data in the form of a table, like this particular column, this particular row, just modify this value to something. If that data is stored in a file, you'll have to rewrite the file. And imagine having to do this rewrite millions of times. Is going to be very inefficient. That's where a NoSQL database comes into. It's the same argument like, why do we need a database in first place, right? So that we can interact with data in the form of table structure and modify the data in the form of table structure. Did I make sense to you? That's right, Krishna. So if you are just storing files such as the web logs, then we don't need HBase. You can just keep on adding that to HDFS. But if you want to, as and when logs are coming in, you want to take out, parse it, and forms the columns and rows, then like at this time, this particular component said this message, and so on. If you want to continuously break down the log and complete it into structured or semi-structured, then you will need HBase. So you need HBase to store fast incoming data, or modifications when you need to modify data row-wise, column-wise, tabular structure, and so on. In those cases, you need HBase. HBase is tightly coupled with HDFS, meaning HBase cannot run on any other file system. A question from Manu. Through HBase, can we query? No. Unfortunately, HBase out of the box does not provide a query engine, but using systems like Hive, we can query HBase. Krishna's question is, do we need to store first file in before storing? No. HBase, basically you create a table in HBase, start putting data into HBase. Internally, it will keep its data files in the HDFS. Can't we interact with the files without HBase? The HBase data file you don't want to fiddle with, honestly. Okay. Okay, so HBase does not provide you a query engine. It only provides you get and set kind of interface where you say, give me data in this column, this row, and it'll give you that data. Okay, so HBase, there are third-party tools which are providing query engine on HBase, but HBase out of the box does not. All right. Very good questions coming in. Let me just try to see if I can answer quickly. Okay. Srini, was I able to answer your question? HBase is a server. Okay. HBase is a server like a database server, and you do a get and put to HBase. Yes, it is more like Oracle, just that it does not provide you a good query engine out of the box. There are third-party libraries or Hive kind of tools that provide a query over HBase. All right. Yes. Kurt's question is, whereas in Cassandra and MongoDB, we can directly query. Yes. In Cassandra and MongoDB, both provide their own query language. All right. A question from Mahmood is, can we replace HBase with other NoSQL tech like MongoDB? You can, but the problem is you'll have to install MongoDB on all the nodes. Okay, so that's why people prefer to use HBase if you have Hadoop system already. A question from Manu is, if we create tables in Hive internally, where will it go? To HBase? No. If you create tables in Hive, they are stored. Tables have two parts. One is name of the table, column of the table. We call it metadata. And then the actual data. Actual data go to HDFS when you load in Hive. And metadata is stored in maybe MySQL, whatever database you configure with Hive. Hive needs you to provide existing SQL database, okay, to store the metadata. We'll go into the details. We'll go into the details as we go forward. All right. Question from Rahul, how Hive and HBase interact? Hive and HBase interact by the way of MapReduce. Okay, so you give the query to Hive, Hive converts into MapReduce, MapReduce runs on HDFS. Okay, but we will be writing our SQL for querying Hive. Okay, Preston's question is, what difficulty would I encounter if I simply subtract HBase from HDFS, Hadoop HDFS? It doesn't matter. So when you subtract, what does it mean? Do you want to remove HBase from the Hadoop ecosystem? Or you want to install HBase without HDFS? So it's not possible to run HBase somewhere else. Okay. A very good question from Kar. What kind of hardware is required to HDFS? HDFS can be installed on any commodity hardware. Okay, it doesn't require a very high-end system. We have installed on very low hard drive systems such as 200 gigabyte. So HDFS or Hadoop is designed to run on commodity hardware. Okay. Can Yarn be thought of as an OS and HDFS like EXT? Yes, you can think of it that way. What is the type of HDFS since it is a file system? So HDFS is a network file system, and under the hood, it uses the native native file systems. Okay, we will go into the details and then you will know what does it mean by HDFS. HDFS under the hood actually stores data on many machines, and when it's storing data on many machines, it uses the native file system. All right, so Prasoon, was I able to answer your question? What difficulties would I? Okay, wonderful. All right, so going back to the architecture of Hadoop ecosystem. Next is computation engine. Since our data is humongous, stored on many machines under the hood, when we run our logic, we would use either MapReduce or Spark. Both MapReduce and Spark run using Yarn. Okay, MapReduce is kind of a workload. We'll write our logic using two functions, map and reduces, hand over it to MapReduce. MapReduce runs it on the data and then sorts it and runs your reduce. First it runs maps nearer to the data, then orders it, then hands over to the reduce, and then saves back to the HDFS. So MapReduce is a computational framework or computational engine or computational workload, if you think about uh, Yarn. Okay, so MapReduce is the way of executing program in distributed fashion. All right, and since writing code was not really a great idea for every small problems, people design things like Hive and Pig, where you write your logic in the form of SQL query, and Hive or Pig, they convert that query into map and reduce and execute it on top of Yarn so that the computation could be done on thousands of machines near to your data. And that's where these tools work together. So you write your query in Hive, data is in HDFS because the table that you have created in Hive, the data is in HDFS. So when you write a query in Hive, that query gets converted into MapReduce. MapReduce runs it on Yarn, and Yarn runs that query near to the data that you are trying to query in Hive. Okay, that's how the model works. A question from Pius: HBase is always the best option with Hadoop, or it depends on the use case? We can use Cassandra and MongoDB. So in my honest opinion, for many use cases, when we will do the analysis of these three, uh, for many use cases, Cassandra might be a better option than HBase or MongoDB, but HBase is also pretty good for most of the problems. Okay, now with Cassandra and MongoDB, you might have to install those in your cluster. They don't come pre-installed with Hadoop. While all these things that we are talking, plus many more, they come pre-installed with Hadoop. Okay. A question from Kerr: we can use MapReduce or Spark, or we need to use both? You can use either. Today, as we talk, Spark is able to do everything that was possible by MapReduce and much more. Therefore, we do not really need MapReduce much. Therefore, we have cut down the dose of MapReduce in our classes. We're keeping MapReduce because MapReduce is a way of structuring your logic, and therefore we would like to understand that. Okay. All right. So therefore, anything that can be done with MapReduce can be done with Spark. All right. Good. Let me answer two more questions. All right, Kar, was I able to answer your question? Good. Now, question from Krishna, will it take care of target HBase or file system if we store data in both the places? Okay, let me see if I understand. Okay, actually, I did not understand your question. Is it take care of? Yeah.
I mean, Hive, when you are extracting data from Hive,
Mm-hmm.
would it go to HBase as well as file system? The query, how it works, that's what's it.
Okay. So yes, when you are defining your table in Hive, you can mention that this table is actually in HBase, and therefore, while it runs your query, it will read data from HBase instead of reading data from HDFS. So it basically, while defining your table in Hive, you have to do that. Okay. So I mean, while creating Hive table, you can define that my data is in Hive, is in HBase instead of HDFS, and that's what will the lay down the foundation of the query execution. Did I make sense to you? All right, great, wonderful. Now going ahead with a question from Sudhakar: is Hive runs on MapReduce and not on Spark? Okay, a question is, does Hive runs only on MapReduce and not on Spark? Traditionally, Hive used to run only on MapReduce and not on Spark. It's a very brilliant question, and it's difficult to answer right away. Let me try. So Hive was designed such that people could write SQL queries and that get converted to MapReduce. But Spark guys were really clever. They realized that lots of people have written queries in Hive. Okay, so whatever queries people have written in Hive, Spark is able to take those queries and able to execute those queries without using MapReduce. Okay, that's the clever part they have done. So instead of Hive running your queries, is the Spark that runs your queries. It basically, whatever queries or table you have defined, it consults Hive's meta store, okay, metadata, and then it starts running it. And we will see this as we go forward, that how to run query using Spark instead of Hadoop MapReduce. Okay. Okay. Now there are very wonderful questions coming in. All right. Just that the time is running away and I wanted to cover a little bit more. So Cassandra work on top of HDFS? No, Cassandra does not work on top of HDFS. They have their own file storage. A question from Nitesh, can we set up complete ecosystem on one or two machines? I want to have a solution without having any paid software. So rather than paying high license cost of Oracle, I can use big data, even if data size is not big. So yes, you can. You can install on one or two, okay? But the bigger question you need to answer is, what solves your problem? There are quite a few problems like, for example, if you have transactional data and you want to process that data, you want to store or modify the data continuously in a transactional way, then probably this ecosystem may not be of much help to you. Okay, but the other things like churning, processing the data, you can install it easily on maybe 2-3 machines and it'll run fine. We started our CloudX lab with 3 machines. Okay, so generally 3 machines are sufficient to run the ecosystem. A question from Manu, if we create a table in Hive, what is the relation between HBase and with that table? No relation with that table. So unless while creating table in Hive, we mentioned that this table is actually related to some table in HBase, unless that point, that Hive table will point to the data in HDFS. All right. A question from Pius: is Spark bounded to HDFS only? No, it can be used independently. It can run on, it can process data from Cassandra, HDFS. In fact, it was designed to run on Tachyon, another open source project, competition of Hadoop distributed file system. So therefore, they have designed it such a way that it runs really well with most of the storages. Okay. Question from Sahida. Will there be a context switching overhead when a query in Hive translates to HBase, then to MapReduce, having an impact on performance? Not really. These translations cost few milliseconds, while the kind of processing we do on Hadoop takes hours. Okay. Therefore, few milliseconds don't matter at all. Kurt's question is, why do we have MapReduce in architecture? MapReduce is a software framework, and therefore it's a component, independent component. All right, and it's a part of Hadoop ecosystem. A question from Masood: I have logs in different systems. Do I need to put Hadoop in all systems, or I take the log from all and give it to the central Hadoop system? The second option is better. Okay, you install something called Flume, we'll talk about in a minute, on all the machines, and that will push the data centrally. Hive has query syntax to query unstructured data also. It has query syntax to process semi-structured data. Although unstructured data can be processed with Hive, okay, but it becomes little too complex. If Spark can do everything, why do we need MapReduce is my question. My quick answer is that we don't need MapReduce too much in today's time, but it is there for the legacy reasons, and because there are lots of components that are depending on MapReduce even today. Okay, good. Similar to Hive, you have Piglatin. It's a new kind of SQL kind of language, but far more simpler. Next is Oozie. Oozie is a workflow engine. All right. When you have a job, okay. On the other side, before Oozie, I would like to talk about two things: Scoop and Flume. Let's say you have traditional database and you want to move that data to either HBase or HDFS, or you have data in unstructured format like logs being generated on many servers. Okay, parallelly, in that case, you use Flume. If you have structured data and you want to move it from your SQL, Microsoft SQL, MySQL, Oracle, you want to move that data, then you use Scoop. All right. So you use Scoop and Flume for importing and exporting data. Flume is specifically designed for unidirectional flow, as in, if you have many machines generating data and you want to continuously pump that to a central storage of HDFS, then you use Flume. We'll take example of all of these components and then you will have clarity. Next is Mahat. Mahat runs on MapReduce. It is a machine learning library which has all the complex algorithms in it, and that too runs on MapReduce. It's being rewritten to run on the top of Spark. Okay, a user can either use a workflow system like Oozie, in which, because a typical project will contain many things to be run in a sequence or in parallel, in those cases you will need either Oozie, or your user can use a command line interface, web interface, or Java or Python, or the other languages like, okay, like Shell or others. All right, so these are the components of Hadoop ecosystem. All right, Now, next is Apache Spark. Apache Spark is really fast MapReduce. Okay, it builds on the similar paradigm. It can run on top of Spark. Spark can run on top of Yarn, EC2, standalone, and Mesos, meaning the way MapReduce only ran on top of Yarn, which is yet another resource negotiator. Spark can run on all kinds of resource manager. And even if you don't have a resource manager, you can use Spark even then. You can run it standalone. Let's say you have fresh new machines and you want to run Spark. You can install it on those machines and run it standalone. That's the beauty of Spark. Spark can read data from all kinds of sources: HDFS, HBase, Hive, Tachyon, and Cassandra. All right. And the tendency of Spark is that we will build the connectors to all kinds of data sources rather than building our own data sources. All right. So on top of Spark, you have Spark's libraries. Okay, one library is data frame, where we represent data as a data table. The other library is streaming, which converts a frequently coming inflow of data into batches and runs your logic against that batch. Third library is MLlib. This is very powerful machine learning library. And fourth is GraphX. When you want to process complex graph such as social network or graph between relation between the pages or relation between Twitter handles, that's a graph. If you want to process a graph, GraphX is probably the best library which can handle data, very humongous data using many computers. Okay, and user can interact with these tools using R, Java, Python, Scala, or SQL. So no matter what language are you coming from, you can use these libraries in Spark easily. Okay, and Spark provides you a way to execute logic in a distributed fashion nearer to the data, such as HDFS, HBase, Hive, and Tachyon. All right. So to do the distributed computing efficiently, Spark would be your one single place. A question from Pius. Interact means client requests go to Spark. Yes, client as in you as a user can interact with Spark. Okay, but not your end consumer who is coming to your website. Okay, that you have to install maybe a server or something which will keep the results and display, because Spark is mostly for ETL, extract, transform, or load, or processing complex data in real time or in the batch wise. Okay. All right. Is the ecosystem clear to all of you? There are a few questions which I have not yet answered. I would love to answer those questions now. All right, let me answer your questions now. How much Apache Spark is covered in the course? We will cover only the basics of Hadoop, okay? And then we'll move to Spark. So we have increased the amount of time we spent on Spark than on Hadoop in this course. And most of the computation have actually moved to Spark. So we will only spend some time on Hadoop, that amount of time that's generally required, and we keep on decreasing that time. For example, we have decreased the time that we spend on Pig, and even Mahat we have removed. So we are basically changing that every time. Okay. All right, there are a few questions. Let me answer those questions. Any tools for semi-structured data? Semi-structured data can be handled with Spark as well, with Pig as well as with Hive. Okay, and we'll do that. Okay, Subham's answer was Golang. Yes, I think they have even MapReduce. Yeah, MapReduce can be done in Go as well as Spark can be done. Okay, Pius's question is interact means, okay, I think I've answered this question. Kurt's question is where you place tools like Tableau in the architecture on top of Hive. Yes, yes. So Tableau is a presentation framework, the way we look at it. And Tableau is not really designed as big data system. It is more designed with the small data databases, normal SQL databases. But since Hive provides the connector so that people can execute their SQL query over same database kind of interface, therefore Tableau is able to utilize that. Okay. So Srini, are you going to share the presentation? Yes, we are going to share these slides with all the team. So while creating the table itself, we need to mention whether to store in HDFS or HBase. Yes, Manu, that's right. Sayed's question is, can you please come to Hadoop components slide, which cover all the aspect? Sure. Okay, this one. A question from Krishna, is Spark should be mount on HDFS or independent? So Spark does not need to be installed, okay? You hand over a Spark, every time you run a query, you just download it, tell it to run on Yarn, it'll run on Yarn, okay? We will show you that part. If you are confused about this, take a look at our blog. Take a look at our blog. I'll show you the blog again. I will show you Spark, okay? And so, yeah. So this particular blog post which we did shows how to run something on top of Yarn. You can download your new version of Spark and tell via these environment variables that, hey, my Hadoop is installed there, go run there. So you don't need to explicitly install Spark on Hadoop cluster, okay? You just have to download it on one machine and then run it and tell it where is your Hadoop and it'll go there and run. Okay. All right. So where were we? Okay, we were here. Somebody was asking me to go back to this slide. So I think Sayed was asking. All right. So how matured is Spark's MLlib as comparing to Python's machine learning library? So if we, yeah, that's a very good question. Yes, we will share this recording session definitely with all the people. All right, go up. I'm just going up. Yes. A question from Ravi. Do we need to have knowledgeable in Java or JavaScript for this class? Not really. If you have ever done any programming, come to the class. That should be good enough. A question from Pius. Why normally prefer Scala with Spark than other language? Because Spark is written in Scala. All right. Therefore, that's the reason why people prefer Scala. And the other reason is, let's say Python, the second most popular language with Spark is Python. The Python library is a secondary library. Therefore, some of the functions are not updated with the Python library. That's the reason why people prefer Scala. Also, some of the components of Spark ecosystem do not have Python library. For example, GraphX is still only in Scala. A question from Sunny, how matured is Spark's MLlib as compared to Python's machine learning? So MLlib is, yes, MLlib is far more mature than any other distributed machine learning library, comparing with Graph Create. Okay, there's a component called Graph Create, which is you have to pay for using that. And there is another library called Mahoth. So out of all the distributed library, MLlib is most powerful. But Python's machine learning has been there around for very long time. Say SciPy or NumPy, they have been around for quite long. Or Pandas or scikit-learn, they are around for some time. So Spark's MLlib is not that great as compared to Python's machine learning libraries. Okay, but you can use these libraries along with on Spark. Okay, all these Python's libraries can be used on top of Spark to run in distributed fashion. Kurt's question is, where is Splunk used? Splunk is kind of similar to trying to run the things in a distributed manner. So they are comparing themselves to MapReduce or Spark. Okay, or Spark streaming explicitly. So next question is from Masood. Where we run query in Hive, then it moves to Spark and Spark processes it on HBase. Is that correct? When we run query on Hive, it moves, no. So when we run query on Hive, it runs on top of, it gets converted and translated into MapReduce, and it can read data either from HDFS or HBase, depending on where does the table of Hive exist. Okay. If one uses HBase NoSQL data store, then do they lose benefit of distributed computing? No, they take the most advantage of distributed computing by putting data in HBase, right? Because HBase is heavily distributed. A question from Ravi. Will we be using the CloudX Lab or our local? We will be using CloudX Lab for our own all classes. Okay, I would help you in installing this if you want, but honestly, you won't be using any of that. You can download a virtual machine, try to set it up, but we will be using CloudX Lab for this. Okay. A question from Srini. Can we install all the required software on our local machine instead of? Yes, you can, provided you are running, say, CentOS or any Linux machine, you can definitely do that. But it'll be little too, I mean, there are hundreds of tools that you need to install. So it's better to just use the virtual machine. So Kurt's question is, what are the popular representation tools for big data? In the big data ecosystem, it's not. Okay. In the big data ecosystem, presentation tools are not there. Instead, you use the existing small data presentation tools like Tableau and others. A question from Pradeep. Do I need to learn Python? I know core Java, as looks like this course covers Scala. If you know any basic language, that'll be sufficient. We will anyway cover Scala for Spark in this course. Okay. Okay. Thank you, Sayed, for that. A question from Piyush. Can't we merge the last two layers into one? Both are client for sending and requesting. You mean this one or Spark one? Which one we are talking? Piyush? All right.
Hello.
Yes.
Yes, sir. I'm talking about the last two layer like CLI, Java, Python, and Hive, Pig, and Mahout.
No, actually, see, these are three separate components. Mahat, Pig, and Hive are separate components, and user is generally interacting via client interface, Java or Python, to either
Okay.
MapReduce, Mahat, Pig, Hive, HBase, Yarn. To interact with all of these components, the user can either use Uzi, or user can use either Java, Python, or any other language, or command line interface as well as the web interface. All right?
Okay. What I am thinking is SQL interface in Java or Python, any client library is optional. I means
You can use
either
any of these libraries.
either client will send request using the code, either is using the Hive or whatever.
Right, right. So these, I just try to demonstrate that for accessing these tools, a user can use either of this, but there are some components which don't provide command line interface, but most of these
Okay.
provide a command line interface. Some provides a Java API and some do not. Some provide Python API, some do not. But in general, this is the way the user interact with Hadoop ecosystem. All right,
Okay. Thank you.
all right. Great, great, Pius. Right. Okay, Krishna's question is, what is a good in MongoDB? What is good in MongoDB from HBase, as many are moving? Okay, so I'm not sure if people are moving to MongoDB from HBase. If you say that people are moving to Cassandra from HBase, I would kind of agree. All right. So the only difference between MongoDB and HBase is that MongoDB does provide its own query language, which HBase does not. But other than that, HBase is also pretty decent to store humongous data. The other difference between HBase and MongoDB is, in MongoDB, every record can be a complex object, while in HBase, every record is a flat array of columns. Okay, that is one of the differences. All right, so that's pretty much about today's session. We will continue our discussion from these stack, and we will go into more details about Hadoop distributed file system. We will start our discussion from Hadoop distributed file system. All right, so I will see you tomorrow at the same time. All right, and thank you for giving me 14 more minutes, because we had some more questions. Yes, ID would remain the same. No, the ID will change. Actually, the Zoom meeting will be different for tomorrow's session. That will be communicated to all the people who have enrolled for the course. And feel free and stay connected. If you have any question, feel free to write to us at reachus@knowbigdata. And I look forward for your questions tomorrow. Tomorrow's session will be 8 p.m. IST. And all right, definitely I'll be sharing presentation and recording with all of you. And yes, okay. So feel free to drop us more questions at reachus@knowbigdata, and we would love to answer your questions. And stay connected. All right. Thank you, Pius. I'm happy that you found it really good. I look forward to see you. All right. Good. Thank you, Sayed. I'm really happy and I enjoyed your questions. All right. So one more thing, that those who have not registered for the session, actually we have not announced our next course. We'll be announcing the next course shortly, and this course is kind of full. Okay, the batch is kind of full. So just wait for some days. We will be announcing a course very soon, the next course. All right. But feel free to drop me a mail. Okay, so if you need to leave early on certain days during my course, the video gets recorded and gets uploaded after the session. It might take 3-4 hours to upload. Okay, a question from Alvin. What is the start time tomorrow, Pacific Standard? Let me just check. And 8 p.m. IST in PT, right? Pacific Standard. So it is 6:30 a.m. All right, 6:30 a.m. tomorrow. Looks like a little early for you. Okay, Sayed's question is, what is the course fee? You can check nobigdata.com. There you will see the course fee. Okay, and yeah, I'll be communicating the next batch. The current batch is kind of full, and it'll be difficult to accommodate anymore. All right. Yes, Shiva, the recordings are available. Yes, this course is just over the weekends. Sure, ready. I'll be sharing the recordings before tomorrow's session. Sure. And I think EST would be 9:30 a.m. Let me just see. 8 p.m. IST to EST. Yes, that's right. Thank you, George. All right. So great. And thank you, Zabulo. I look forward for the discussion. Yes, this course is only on Saturday and Sunday. All right. So thank you, everyone. Thank you, Ajit. Thank you, Chaitanya. Thank you, George. Thank you, Ayan Murthy. Thank you, Indiran. Thank you, Indersan. Thank you, Krishna. Thank you, Malreddy, Masood, Mohit, Piyush, Rajsekhar, Rajat, Ravi, Reddy, Roni, Sahida, Shiva, Shubham, Sijo, Alvin, Hang, Mahmood, Narendra, Pradeep, Rahela, Sudhakar, Sunish, Srini, Prasun, Mohsin, Shamit, Srini, Vikas, Ravi, Sunny, and Sayed. All right, great to have all of you to in my session. I totally enjoyed your questions, and stay connected with us. And I would love to answer your questions. And we will be sending you the slides and presentations, slides as well as the video. And those who have already enrolled, the video and the slides will be available in the LMS. It'll take around 2 to 3 hours to finish and upload it. All right, great. Bye-bye. All right, thank you, Saeed. I appreciate your feedback. Okay, great. Bye-bye. Have a great day ahead. I look forward to see you tomorrow. Good night and good morning for everyone, the others from ET and EST. Bye-bye.